Everyone laughed, not a polite laugh, not the kind people swallow out of respect. They laughed openly from truck windows, from porch rails, from across fences, because week after week, a 17-year-old boy named Ethan Ross was loading discarded, cracked irrigation pipes into an old flatbed cart and hauling them back to his family's drought-worn farm on the edge of Kern County. Nobody asked him to. Nobody paid him to. And nobody could figure out why. Old Oscar Pruitt from the next lot over shook his head every time he saw Ethan dragging another pile down the road. "Boy's losing his mind collecting that junk," he told anyone who'd listen. The pipes were cracked, warped. Some had been baking in direct sun so long they'd gone brittle. The fittings were corroded. Whole sections had split clean down the middle. 3 different farms in the valley had thrown them out specifically because they were beyond repair. Ethan collected every single piece, he sorted them, he cleaned them, he measured them, and he never once explained what he was building. By the time harvest season arrived, those same neighbors would make the drive to the Ross farm. Not to mock him, but to understand how a boy with no budget and a pile of broken pipes had transformed 11 acres into one of the most water-efficient small farms in the county. But that part of the story comes later. First, 3 questions nobody could answer. Why was he collecting pipes that 3 farms had already thrown away? Why was he sorting them so carefully by size? And what on earth was he drawing in that notebook? If you believe that overlooked things can carry extraordinary value, subscribe, because that's exactly the kind of story we tell here. And drop a comment letting us know where you're watching from. This community stretches across the world, and we genuinely love seeing that. The Ross farm had been in the family for 3 generations, 40 acres originally, now 11. The rest sold off over the years as costs climbed and rains became unreliable. Ethan's father, Frank Ross, ran the operation the way his own father had taught him. Row crops, seasonal rotation, and a gravity-fed water line that had served the property since the 1980s. But that system was failing. Joints leaked. Pressure had dropped so badly that the outer rows of their tomato crop were receiving barely half the water the center rows got. Water costs in Kern County had increased 40% in 6 years. Replacing the irrigation infrastructure was estimated at over $22,000, money the Ross family simply didn't have. Ethan had grown up watching his father file water usage reports, adjust schedules, and calculate exactly how many gallons each row needed. He hadn't studied agriculture in any formal sense, but he'd absorbed it the way kids absorb things when a problem lives in the same house they do. One evening, driving back from town with his father, he spotted the pile of discarded PVC behind the Ramos property. Gray, sun-faded, cracked in places, clearly destined for the landfill. He asked Frank to slow down. He got out and walked the pile. He didn't say anything on the ride home, but the next morning he was back with the cart. Over the following 3 weeks, Ethan made 7 collection runs. He wasn't indiscriminate about it. That was the first thing that surprised people who watched him closely enough. He wasn't just grabbing whatever was available. He carried a small spiral notebook and a measuring tape everywhere. Sections got measured for usable length. He only kept pieces with at least 4 uncracked feet. He tapped joints to test wall thickness. He marked each piece with a paint pen, diameter, pressure rating, if he could find it stamped on the side, connector type. He set up a sorting system in the barn, 4 rows. 1/2-inch line on the far left, 3/4 inch next, 1 inch after that, 1.25 inches on the right. Each row subdivided further by wall thickness. He cleaned every section, removed dirt, old tape, corroded fittings. Anything with a hairline fracture that ran more than 2 inches got set aside in the discard pile. Nobody asked him what the plan was, partly because the Ross family were private people, but mostly because the neighbors had already decided it was pointless, and they weren't curious enough to challenge their own conclusion. Ethan kept drawing in the notebook diagrams, measurements, elevation marks, and in the corner of one page, a rough sketch of a raised platform, something to set a tank on, positioned uphill from the field. What was he mapping? The answer started to take shape when a woman named Diane Calloway came out to the Ross farm in late April. Diane wasn't magic. She wasn't a mentor from a movie. She was a water conservation specialist from the UC Cooperative Extension Office in Bakersfield, and she'd heard through the County Agriculture Network that Frank Ross was struggling with pressure inconsistency across his irrigation lines. She came to assess. She ended up staying 3 hours. When she saw what Ethan had laid out in the barn, she got quiet. Then she started asking questions. "What's your elevation change from the water tank to the lowest row?" Ethan showed her the notebook. She studied the measurements. She explained something that most people outside farming never learn. Water doesn't need mechanical pumps to move. It needs gravity and the right pressure differential. A water source elevated even 8 feet above the field can generate enough pressure to feed a properly designed drip irrigation network if the pipe diameters are sized correctly to compensate for friction loss as the line lengthens. She pointed at his sorting system. "Why did you separate by diameter?" "Friction changes with diameter," Ethan said. "Smaller pipe, more resistance. I need consistent flow at every emitter." Diane looked at Frank. Frank looked at his son. She explained further the concept Ethan had arrived at through observation was a working version of what irrigation engineers call a low-pressure drip manifold, a branching network designed so that water reaches every emitter at roughly equal pressure, even across uneven terrain using no electricity and minimal infrastructure. It's used in parts of India, sub-Saharan Africa, and increasingly in drought-stressed regions of the American Southwest, but rarely assembled from recovered materials. Diane agreed to consult. She brought a copy of her extension office's low-pressure irrigation manual. Ethan had already marked a dozen pages that matched what he'd drawn. Installation began in May. Ethan, his father, and a neighbor's teenager named Tyler Marks worked 3 weekends laying the network. The first test run failed, not catastrophically, but definitively. The far eastern section, the longest lateral line running nearly 90 feet, was receiving less than 40% of the flow the western section was getting. The emitters at the end of the line were barely dripping. Ethan didn't panic. He walked the line, slowly measuring output at each emitter with a small catch cup and a stopwatch. The problem was the junction at the main header. He'd connected a 1-inch main line directly to a 3/4-inch lateral without a pressure compensating reducer. The pressure drop at that transition was too sharp, and the friction loss over 90 feet was starving the distal emitters. Diane had warned him about pressure zones. He'd understood it in theory. Now he understood it in practice. He redesigned the header junction. Instead of dropping directly from 1-inch main line to 3/4-inch lateral, he inserted a tapered reducer fitting and extended the transition zone over a 6-foot run, slowing the pressure drop gradually rather than abruptly. He also recalculated the elevation of the secondary tank, raising it 14 inches on a platform he built from salvaged barn lumber. More height meant more head pressure, which bought him the margin the long eastern line needed. The second test run showed even distribution across all 4 lateral lines. Every emitter dripped at the same rate. What Ethan had assembled was a gravity-fed, low-pressure drip irrigation manifold, built almost entirely from materials that 3 different farms had considered worthless. The system fed 11 acres through a branching network of recovered PVC pipe, with drip emitters spaced to deliver water directly to root zones. It ran on gravity alone, using a repositioned storage tank fed by a rainwater collection array Ethan had added to the barn roof and 2 outbuildings. The logic was elegant in the way that truly useful things often are. By delivering water directly to root zones at low pressure, the system reduced evaporation by roughly 60% compared to sprinkler-based watering. Soil moisture stayed consistent across rows. The outer tomato rows, the ones that had been drying out for years, were now receiving the same volume as the center rows. Water usage dropped by nearly half, and rainfall the property would have previously lost as runoff was now being captured, stored, and redistributed. The total cost of materials Ethan hadn't found for free, $47 in new fittings and one replacement emitter kit. Diane brought 2 colleagues out in late June. Leonard Delgado, an irrigation systems consultant from Cal State Bakersfield's agricultural department, walked the lines for nearly an hour without saying much. Then he crouched down at a mid-row emitter junction, checked the output rate, stood up, and turned to Diane. "The pressure compensation across lateral length is better than systems I've inspected at 10 times this cost." He noted specifically that Ethan's use of a gradual pressure transition at the header junction, the fix he'd developed after the first failure, demonstrated an intuitive grasp of hydraulic resistance principles that most first-year irrigation engineering students struggle with on paper. The design wasn't perfect. Leonard suggested 2 modifications: a fine mesh pre-filter on the tank outlet to prevent emitter clogging, and a slight repositioning of one lateral line to improve drainage at the field's low point. Ethan made both changes within the week. By August, the difference was visible from the road. The Ross tomato rows were uniform in a way they hadn't been in years: consistent canopy height, consistent fruit development. The outer rows, which had historically yielded 30% less than the center, were matching center row production for the first time in Frank Ross's memory. Water bills for July came in at just under half what they'd been the previous July. During a stretch of 12 days with no rain, the captured rainwater supply kept the system running without drawing from the municipal line at all. Word spread the way it does in farming communities, not through announcements, but through people noticing things. Oscar Pruitt walked over from next door in the 3rd week of August. He didn't announce himself. He just leaned on the fence at the edge of the tomato section and looked for a long while. 2 other neighbors, the Ramos brothers, whose discarded pipes were now part of the system, pulled up not long after. They stood together without talking much, taking in the even rows, the deep green canopy, the absence of the dry patches that had always marked the Ross field's edges. Ethan came over. "We thought you were just collecting junk," Oscar said, not unkindly, just honestly. Ethan nodded. It looked like junk, but it still held pressure where it mattered. One of the Ramos brothers glanced at the lateral lines running along the row bases. "That's our old pipe out there, isn't it?" "Most of it," Ethan said. Nobody said anything for a moment. Oscar broke the silence. "You should have told people what you were doing." "I wasn't sure it would work," Ethan said. "Seemed better to show it." There's a particular kind of intelligence that doesn't announce itself. It watches, it measures, it fails quietly, adjusts, and tries again. It sees potential in things other people have already decided are finished. What Ethan Ross built wasn't just an irrigation system. It was a demonstration that the distance between waste and resource is often nothing more than understanding. The pipes hadn't changed. They were the same cracked, discarded sections that 3 farms had thrown away. What changed was the knowledge applied to them and the patience to sort, measure, and design before ever connecting a single joint. In agriculture, this kind of thinking has a name. Farmers call it working with what the land gives you. Engineers call it constraint-based design. Most people just call it making do. But it's more than that. It's seeing the actual value of a thing rather than the conventional assumption of its value. The soil is the great connector of lives, the source and destination of all. Water is its companion, and the systems we build to move water, however humble, however salvaged, determine whether that connection holds or fails. Ethan Ross, with $47 and a flatbed cart full of broken pipe, kept the connection. What part of this story stayed with you the most? And where are you watching from? We'd love to know. If stories like this matter to you, stories about ordinary people finding extraordinary solutions in overlooked places, subscribe. We find these stories because we believe they deserve to be told. And if you have a story about someone who saw value where others saw waste, drop it in the comments. We read every single one. Until next time, keep looking for the value in overlooked places. You never know what you might find.